Happy to present this lecture 5. This time we'll talk about the concept of distributed primitive. This time different from the introduction in the previous presentations. This time I will give you a detailed introduction about the distributed APIs and their design patterns, how they look like. I will show you code for this time. Here's some reference. I'm still working on this technique, so I need to publish more articles and even books. But this is some simple. This reference is not so new, so I will maybe near future I will upgrade it. Here's just some other references. So the concept, you must understand the concept distributed primitive. There are some, based on my knowledge, I propose those them. So based on my understanding, distributed primitives are very important, the fundamentals of distributed system development. In grade 3, all the distributed system, even all the distributed frameworks and all the distributed APIs are created with those distributed primitive APIs and design patterns only. We do not need to use any other techniques to implement any complete distributed system frameworks and APIs. So they are the fundamentals. If say I give you another example. Somebody may, if you program with Java, I give you an example. If you program in Java, you must know that Java has a lot of APIs, right? If you go to the web, search the Java API, you can get a lot of APIs from Java. But the Java API, in terms of distributed system programming, I don't think Java have a proper API to speed up the development of distributed system. So that's why I need to propose such APIs. So those concepts you must understand. I talked about that before. And Java only proposes some threading and networking. That's all. Just standard addition or call Java. That's all, right? They have no any other support to help developer implement distributed system. For the complete distributed system, complete one distributed framework, distributed system, complete distributed APIs, it's almost impossible for us to use Java. It's so difficult. So if the effort is so high, it becomes almost impossible. So I have to propose some new APIs to do that, rather than using Java APIs. In some other languages, for example, Python, C++, or C, yeah, that's the same. They just provide some very fundamental techniques, threading and networking, but both of them are too far away from distributed programming. The developer have to overcome a lot of issues, overcome a lot of problems before a distributed system can be constructed. So let's take a look at this. The distributed patterns in grade 3 can be categorized into two types. The first one is API, distributed primitive API. It can be can be shortened as DPA, distributed primitive API. Another portion of the distributed primitive is the distributed primitive patterns. I call it DPP. It's shortened as DPP. These are two types of two components of distributed primitives. The API, yeah, I already know API. but the API need to be constructed together to be organized together, to be composed together, to integrate together to construct a system, right? How to do that? How to integrate? How to compose? How to use those APIs? How to merge them together, band them together to a distributed system that we can, if no API, no patterns available, the developer have to explore the integration based on their knowledge. It must be time consuming. It consumes a lot of efforts. However, if we already invented some distributed patterns, developers just follow the patterns to design their system. It saves a lot of efforts. So the idea is this idea is straightforward, although it's difficult to propose that, right? It consumes me a lot of effort to do that. So I will give you introduction to this distributed system in this class. First, we'll talk about API dependence, and then in the later classes, I will program with distributed primitives. Using this distributed primitive DP, I call it DP, then you can construct the simplest distributed framework. The simplest distributed framework is two-node client-server system. In such a system, only two computers is employee. Two computers are employed. One is a client, another server. Both of them interact with each other through lightweight messaging. So from my point of view, this is the simplest distributed system. So if you only use distributed primitives, those original APIs and design patterns, you can construct DNCS at least. However, maybe in the future we need to construct development more complete ones. Then we can compose those API, the DP, in more complicated ways. But for this time, because we just get started, so we just talk about how to use this API in a straightforward manner. So in the future, we are still working on with these APIs and construct a more complete system. For this time, we just use them to program TNCS. TNCS is a cell, right? If two computers can be connected together, I think although some system is very complete, we talk about some very difficult system. For example, the heterogeneous large scale, global scale, heterogeneous socialized distributed system. In such a system, from my point of view, is the most difficult system of the world. However, no matter how complicated it is, the cell, the minimal unit of such a system, is still two computers connected and with lightweight messaging, right? So if that prove that the distributed primitives is why we can use distributed primitive to implement any system, right? Because the cell, any system is constructed come from this is constructed by any large number of a certain number of cells. So if the cell is constructed by DP, then any distributed system can be created with the DP, right? That's I think it's easy to be reasonable. It makes sense, right? So that's why grade 3 is efficiency and generic. It's efficient and generic approach. But I think they still cannot understand it very clearly. We'll talk about this issue later. CS server. This is a first API. The first API I want to introduce to you. I think This is using this server, CS server. Any computer can be converted, can be transformed from standalone computer to a single physical distributed node as a server. I think it should be as a server, right? So if a computer that should runs over a distributed computing environment, it must be a distributed node. So distributed node can be classified as a server, client, or peer. So this is if we want to create a server, then we can use this API. I can show you the code. It's more important to see the code. This is the first time for us to see the programming environment. So let me introduce some. Let me show you the code for the first time. Okay. Here, this is the project. This is a project. I think this is a huge project. It contains about 20,000 lines of code. I'm still working on this code. We can see here the package named GridFreeze Server. Here is API I want to show you. But you can see here, this is underlying. There's a lot of comments here, right? But this is an internal implementation. You don't need to pay much attention to that. When you program with the server, you don't need to know the details inside it. If you are interested, you can take a look at this, and maybe you are interesting to upgrade, improve that. You can download the code from the GitHub. But today I don't want to talk about the inside stuff. I want just to talk about how to program with CS server, what it looks like outside. Maybe we can take a look at the server in this way. Okay. Chat server. Chatting is a very important application at this time, and it's also typical distributed system. In our classes, I will show a lot of application based on the chatting. Chatting, we can, if we want to establish a chatting system. Chatting is lightweight messaging, and so it's easy to demonstrate the one programming technique, the distributed programming technique, right? So that's why I program a lot of chatting server. This is the first one. We say it's very simple, just the two nodes, the client and the server, and the chatting message will send from the client to the server. I don't think this is a real system, because the two users, only one client, so no real users can interact with each other. So the chatting is not a real one. So, but in the next step, I will show you how to create a more practical system that multiple users can interact with each other through lightweight messaging. In such a system, we still use the CS server, but this time only two nodes exist. Two node client server. Next time, maybe the more complex system is multiple node client server. For this, if based on this server, the chatting can be performed, right? Chatting can be performed. However, in this case, since only two nodes exist, one is client, another server, the chatting is not implemented yet. the message is sent to the server, but no chatting really happens. But I think this is the first time that, right? You can at least it's a distributed system, right? So in the near future, I will extend the system and show how can we create a real chatting in the next step. However, at least this is a server, right? We can take a look at this. This is the CS server. This is the first API I want to introduce to you. This one, server, this API, right? According to here, this is the this API is I implement in using generic technique. So beside using this API have a placeholder because it's implement in using generic technique. So it has a placeholder. This placeholder is another API. I will discuss this API later. Just for this time, at this moment, just pay attention to, just focus on CS server. CS server can convert a system from a computer to a server in the distributed computing environment, right? So here, this is server. Server is easy to be programmed. You can see here, stall. There is a method called stall. So the server can be stopped. There is timeout. So some concurrency, maybe some other computer resources will be collected. So we need to have such a parameter to allow the computer resources can be collected. The server, another API. So here, the server can be initialized. The server can be initialized. When I use, because the parameter, a lot of parameters here, right? The server can see here, server is a pod. Maybe here is more clear. This is the class. The server, the name is the CS server, has a placeholder called dispatcher. This dispatcher, I will talk about that later, exactly in detail. And this dispatcher is used to dispatching incoming message, so that can be processed concurrently. And no parent, that is not interface, right? Constructor, there are a lot of parameters here. If we want to initialize a CS server, but I think if you are interested, you can take a look at the parameters. I will not explain that in detail because it's better to show how to program the code first. If the system can be wrong, can be executed, you can learn those parameters in detail, right? First, maybe we'll just take a look. I will not explain that in detail. First, the pod is because I use TCP as a transmission protocol. So the TCP, we need to have a pod number if we want to create a server. The server need to receive messages through this pod. Listener count. I think there is a lot of maybe in the near future, a lot of incoming message. So if we need to process those message, receive this message rapidly enough, efficiently, so we need to have design some multiple threads to listen to this pod. The server has some threads to be managed, so there we have threads the managed by thread pool. So the thread pool need to set some parameters. You can decide the exact value of those parameter parameters based on your specific computing application and environment. Dispatcher is a peer. That means things in the future, peer is more important. So peer is constructed by a client and the server. So if the server will work in the way of a peer, so we need to set up this this parameter. Sorry. This is the method of the server. Get ID. This server has the ID. Get pod. Set ID. Set pod. Start. Stop. I think those API is very simple, right? So it's easy for developer to use. So CS server is easy to be programmed because there's the constructor is simple, the method are simple. This is the first one. Another one is server dispatcher. Server dispatcher is within all the distributed primitive APIs, the server dispatcher is the most important one. Since the server for distributed system concurrence, any distributed system is concurrent in nature, right? Any distributed system is concurrent in nature. So we need to consider after a computer is transformed to a server, we must resolve the next issue. That is a concurrency. How to provide high efficient, high performance, and the distributed concurrency mechanisms on the server is the most important issue. Even the system is very simple. So, however, concurrency programming is difficult for most developers. Even proficient developers are afraid of programming thread directory. So usually it's better for us to use some distributed frameworks to avoid programming concurrency directly. However, as a generic distributed programming paradigm, I need to support concurrency, right? GRID support concurrency for sure. However, using those techniques, using a server dispatcher, it's easy for developer to implement a concurrency system. There are two types of the concurrency here. This is I call it a scaling up concurrency. There's still some other concurrency. This is scaling up. Another type is scaling out. We'll talk about scaling out later. Scaling out means that the computing is performed in multiple computers such as a clustering. At this time, we do not talk about that. In the later classes, we'll talk about how to construct a clustering system. This time, I will, for server dispatcher, it provides a server, a scaling up concurrency only. And if we program a distributed system using DP, distributed primitives, most effort are spent on this API. This is a complete API. It has not only, it's not a simple API, it's also implemented using the generic techniques. So it have a lot of, has a placeholder called the server message. And in the meantime, when we create, there is a complete, not difficult, it's complete, a little bit complete design patterns. In such patterns, that contains some other APIs such as request dispatcher, don't backend. We talk about that later. So almost all the API are associated with server dispatcher. So if you understand dispatcher, I think you almost know how to program with grid-free distributed primitives. If so, that means if you know how to program with the grid-free distributed primitives, that means that indicates that you already grasp the technique to program any distributed system. So that's very promising, right? Very interesting. So I will talk about server dispatch at this time. So dispatcher is an abstract class. I can show you class server code here. Server dispatcher. This is a real code. This is real code. Chat server. You can open it. Take a look. You can see here, this is server dispatcher, right? If you are interested, you can open this code to look at the internals of server dispatcher. I will not talk about the internals of the dispatcher. I just talk about how to use this API for this class. There is a placeholder, the server message. Server message is the top message class, the top base class. All the messages in grid-free should be derived from server message. This is another API in distributed primitive. So server message is when you use, so since it's an abstract class, so you have to implement or inherit or derive, extend server dispatcher. This is one implementation of spec server dispatcher for chatting. So I call it chat server dispatcher. You can see here some other components, programming components, need to be used with server dispatcher. But this time, you should understand server dispatcher is the most important, the kernel of all the APIs on the server to support scaling up concurrency. If you have no idea how to do that, I will show you. Don't worry, I will show you how to program this code. It's very straightforward, although maybe you're still confused about this technique. Don't worry about it. The message can be classified as notification request. So all the message will be sent to the dispatcher, and the server dispatcher will dispatch the incoming message to corresponding concurrency mechanism. How to do that? Don't worry, I will show that later. Excuse me. This is a class, server dispatcher. This constructor, there's some parameters listed here. Thread pool, yes, since concurrency is the most important issue for distributed system. So concurrency, you can see concurrency techniques everywhere. You see that on the CS server here. We also need to set up some initialize some parameters for server dispatcher. This is thread pool, keep alive time, scaling per size. Both of them are thread pool. Scalar per size also a thread pool. This is another thread pool. Maybe this is this thread pool is used to control all the threads on the server. But if you are interested, you can take a look at the inside of this class. But at this time, when we program, maybe next time in the future lectures, I will show how to program that. At this time, because you have no idea how to program with those APIs, you do not need to spend much time on those parameters. But in the future, if the system is constructed, you can spend much time to do some research on these parameters. At this time, you just know those parameters is used to adjust the comparison mechanisms on the server. Method. These are the methods I listed for the so dispatcher. Scheduler is important. So the scheduler usually used to monitor the status of the threads on the server. You can see it's a heavy effort if this task is have to be resolved by developers, right? Shut down. The dispatcher also need to be shut down. Or if they shut down all the computer resources, especially the concurrency mechanism, all the threads should be collected. All the computer resources can be claimed for reuse. Execute. There are two types of execute. That means the so dispatcher need to start some threads. Right? That's normal, right? The threads, if the thread is started, then we can provide concurrency. Yeah. Consume means that all the messages should be processed with this method. This means consume. You can see here, this is how we can initialize. Also dispatcher. Here, we shut down this dispatcher, right? Shut down the server dispatcher for the chat server. This is the process. The message in the documents, I call it the old name, because I still upgrade the system. This code is more it's a newer, it's the latest one, so it looks some difference. In the old word, the old name is consume. Here, now it's upgrade. The slide is a little bit old. Now it is upgrade to process. Today is February 70th. Okay. So a little bit different. But that doesn't matter, right? It's the code is the structure is almost the same. I will explain those code later. Those code I haven't explained. All the code here, those code I haven't explained. I just explain the constructor, some method, shut down, and consume, right? Okay. Next class, notification dispatcher. Notification dispatcher is used to manage the threads to process those threads. Those threads are responsible for processing incoming notification. So, according to this definition, notification is actually a thread pool because it's responsible managing threads. So actually it's a thread pool. All the threads that process different type of notifications should be managed by a thread pool. This thread pool is called notification dispatcher. Actually, notification itself not only a thread pool but also a thread, because this thread is executed by the server dispatcher. So you can see there are a lot of concurrency programming in such a system. However, I just tell you about that. But when you program the code, all the concurrency processing or programming is what I have done internal internal inside the server side, inside the notification dispatcher. You just use some design patterns to construct those APIs. So although here a lot of concurrency issues here, but I just explain. But when you program, almost you at most you just adjust the parameter, but you don't need to know the details. In contrast, you can see how difficult to program a server, how difficult to program a distributed system. Even the system is so simple, just to know, right? However, using my techniques, it become this procedure become rapid and efficient. We need to provide a concurrency because there are a lot of incoming notification from a large number of clients. So we had to use the notification dispatcher to avoid the possibility of overwhelming, right? So that's easy to be understand. This is a class. This is a class. This class looks a little bit complete, right? Notification dispatcher, it has 3 placeholders. The first one is the server message. The server message is a topmost parent of all the messaging. All the message should extend or derive this server message. Notification thread, you must pay much attention to here. This is a thread, but this thread is upgraded. It's not original native thread from Java. It's already updated, so it's easy for you. You can program those threads easily. You don't need to do a lot of underlying the boring or complete threading technique. You do not use them directly. Thread creator is this a placeholder, 3 placeholder here, right? Thread creator is a class that tells the notification dispatcher how to create one instance of the notification thread, because there are a lot of incoming notifications should be processed. If the no sufficient number of threads are available, some new threads should be created. So thread creator tell the notification dispatcher how to create such thread. Parent. The parent is a concurrency dispatcher, but you don't need to modify anything, do anything for concurrency dispatcher. You just learn about that, but you do not need to program that directly. You can here, right? This is a notification dispatcher. This is the real code, real implementation. How we can program such a API. How it looks like in a real application, distributed application. Chat notification, right? This is a first parameter, also first placeholder. Chat thread creator. Here we can initialize it in this way. Constructor. The constructor looks a little bit complete, right? Because some there's more parameter need to be set. The first one is pull side. Yeah, because notification itself is a thread pool, so it's a pull side creator, right? Thread creator is important. So the notification dispatcher need to know how to create the threads. I will not explain all the parameters in detail. If you are interested, you can take a look at the explains later. Since this is video, you can pause the video and read the documents here. I just talk some of the important ones. If I will not explain that in detail. Maximal task size, because there are a lot of incoming messages. Each thread managed by the notification dispatcher is responsible process one certain number of incoming message is determined by maximal task size. These three parameters are used to monitor the status of the threads managed by the notification dispatcher. Wait. Think if the thread is not busy, if the thread is no message to be processed, if the queue of the threads is empty, so the thread should not be closed immediately. It should wait some time. Those threads should be reused. Method dispose is ready. That means the system, the dispatcher may be not started, not ready yet. Some computing resources inside the notification dispatcher is not ready, not initialized. This is a lazy initialization approach. If it's not ready, we just wait. We just need to detect whether it's ready. Then if the message is should be processed, it can be started by the server dispatcher. So this is the method why we design such a method. This is the checking idle checking approach. This is the NQ. NQ means the notification. Notification should be input into the notification dispatcher. The notification dispatcher is responsible for assign all the incoming message to those threads it managed. Wrong. Since itself, notification dispatcher is not only a thread pool, but also is also a thread. So it has such a method called wrong. If you are interested, we can take a look at how it programmed. Here, all the parameters is set here. We use a lot of constants here, right? A lot of constants. You can update the contents if you need. At this time, since they are just a newer, so you don't need to update these parameters at this time. But in the near future, if you want to implement a practical system, you can update you can change the parameters based on your specific computing environments. Dispose, right? When the server is shut down, all so dispatcher, notification dispatcher should be closed. When a message is received, this is the constant. This constant represent one type of notification. When such a notification is received, it should be processed by the notification dispatcher. Should be put into the queue managed by the notification dispatcher. So we need to determine whether the notification dispatcher is ready, because it's a lazy initializing approach to save the computing resource. So we need to detect whether the message is the notification dispatcher is ready or not. If not ready, it should be start up, execute by the server dispatcher. So dispatcher had a message called execute. So it execute by the server dispatcher. And then after this execution, all the computing resources required to process incoming notification should be initialized, and the server notification dispatcher is ready to process incoming message. Because of this, when your server is started, initially, the message is processed a little bit slower than the later time, because it's a lazy initialization manner here. So after this is ready, the message can be enqueue. This enqueue, right? Can be enqueue, can be put into the server dispatcher and then processed by the notification dispatcher. Okay, this is another API I want to record a request dispatcher. But now time is up, so maybe we can talk about this this API later. And I think I gave you a summary about this this lecture. We just gave you some introduction to some of the APIs, distributed APIs, and but I think you don't need to worry about it's because the code looks like a little bit complex, but compared to what we have done, the code is simple actually. And the later case, in later lectures, when you see it's very easy to program with them, program with those APIs, then you can understand the major ideas of GridFree easily. But at this time, you don't need to worry about. I'm trying to explain something, give you just a rough view of GridFree. But I think the best way to show a technique is a programming directory. This is the code, but maybe you have no idea how it's constructed, right? How such a system is established. I will explain that in later classes. In the later classes, the explanation is not so boring. Yeah, I will give you some show you how to program that. I will show the programming procedure step by step in such a video class. Then you can understand my techniques clearly. Okay, that's all for today. Thank you so much.